Hi, let's take a question under maximization and minimization of economic functions and see how to solve it. Question says, a monopolist sells two products, Q1 and Q2, for which the demand is Q1 equals 5,200 minus 10P1 and Q2 equals 8,200 minus 20P2. And a combined cost function, that's DC, is equal to 0.1 Q1 square plus 0.1 Q1 Q2 plus 0.2 Q2 square plus 325. So we have to solve these questions. A says we should find the profit maximizing level of outputs. To find the profit maximizing level of output, the first thing we need to do is to find the profit function, since profit function wasn't given in the question. Now, to get a profit function, let's use this symbol to represent profit. Okay. So pi, which is the symbol, is equal to, profit should be equal to total revenue minus total cost. Okay, that's profit. So since profit is equal to total revenue minus total cost, then we will substitute the total revenue function here and substitute the total cost function so that we can get the profit function. But when you look at the question, total revenue function wasn't given. But we can find the total revenue function ourselves. Okay. Now, total revenue should be equal to, now since there are two products, okay, since there are two products, should be price of the product 1 times quantity of product 1 plus price of commodity 2 times quantity of commodity 2. If you have 3 commodities, then you also add plus price of commodity 3 plus quantity of commodity 3, going that way. Okay. But we have only 2 commodities. Now, if that is the case, now we should have the values of P so that we can substitute them here to get TR as a function of Q, not TR as a function of P. Since what we have for TC is also TC as a function of Q, not as a function of P. But here lies the case that we've been given Q1 and Q2 as a subject. And let's record them and make P1 and P2 the subject. Now, when we recall, Q1 is equal to 5,200 minus 10P1. From this, let's make P1 the subject. Now, to make P1 the subject, we have 10P1 at the side. When we cross the equal to sign to this side, it becomes positive 10P1 because at the side it was negative, equals 5,200 minus Q1 because Q1 was positive at the side. And when it moves to this side, it becomes minus Q1. Now, we want to make P1 the subject, and P1 has a coefficient of 10. So what do? We divide through by what? The coefficient of P1, which is 10. So let's divide through all by 10. So that this 10 will cancel this 10. So you have P1 to be equal to 5,200 divided by 10 should give us what? 520. Okay, so we have 520 minus, there is 1 as a coefficient of Q1 here. 1 divided by 10 is 0.1. So we have 0.1 Q1. So when we make P1 the subject from the first equation, that's what we get. Then we also take the one that Q2 is the subject and make P2 the subject from it. So let's record that Q2 is equal to 8,200 minus 20 P2. Now, to make P2 the subject, this is negative 20 P2, right? So we move it to this side. Thus, it crosses the equal to sign, becomes positive 20 P2 because 8200. When this positive Q2 comes to the side, it becomes minus Q2. Now, since we want to make P2 the subject, we can easily divide through by 20, which is the coefficient of P2. So we divide through by 20. So this 20 cancels this 20. So we have P2 to be equal to, now this 0 cancels this 0. 820 divided by 2 is 410. So we get 410. Minus, now you have 1 here. 1 divided by 20 should give you 0.05. Q2. Okay, so we've been able to make P1 and P2 the subject. So after making them the subject, we can now substitute them into this place to get total revenue. Okay, because we need total revenue as a function of Q1 and Q2. You see that, not as a function of P1 and P2. So we'll get total revenue to be equal to, we are substituting. What is P1? This is P1, right? So let's substitute what we got for P1 here, which is 520 minus 0.1 Q1. So we substitute it there. 520 minus 0.1 Q1. We close the bracket, multiplying Q1. You know, there's another Q1 here. Plus, then P2 is 410 minus 0.05 Q2. Bracket close, multiplying Q2. You see that? So you see that we now get total revenue as a function of Q1 and Q2. But let's simplify it. So total revenue will be equal to Q1 times 520 should give you 520 Q1. Then positive Q1 times negative 0.1 Q1 should give you minus 0.1 Q1 squared. Okay. Then you have positive here. Q2 times positive 410 times the positive outside should give you positive 410 Q2. Okay. And then Q2 times negative 0.05 Q2 times the positive outside should give you minus 0.05 Q2 squared. Okay. So now we know the total revenue function to be 520 Q1 minus 0.1 Q1 squared plus 410 Q2 minus 0.05 Q2 squared. So now that we know the total revenue function, and then we know the total cost function from the question, we can now substitute them here to know the profit function. So profit will be equal to, we are substituting total revenue first. Okay, so we have 520 Q1 minus 0.1 Q1 squared plus 410 Q2 minus 0.05 Q2 squared. Bracket close, minus, then we also take total cost. Please put it in brackets. Okay, so in bracket 0.1, this is total cost function in the question. So 0.1 Q1 exponent 2 plus 0.1 Q1 Q2 plus 0.2 Q2 exponent 2 plus 325. If you do not bracket the TC, it will look as if this negative is only affecting the first term of the TC, which is 0.1 Q1 squared. So bracket it so that we don't make a mistake. So profit will now be equal to, we want to simplify the entire bracket. 520 Q1 minus 0.1 Q1 squared plus 410 Q2 minus 0.05 Q2 squared. Then negative times this will make it negative 0.1 Q1 squared. Negative times this positive will also make it negative. So we have negative 0.1 Q1 Q2 minus 0.2 Q2 squared minus 325. A negative will affect everything in the bracket. Okay, so let's simplify this. Let me draw a line here so that we can write at the other side. Now, profit will be equal to, when you check 520 Q1, is there anything that has Q1 here only without any exponent or something? Nothing. So we write 520 Q1. Okay, then let's look at this also. So we've written this, so it's gone. So let's look at this. Minus 0.1 Q1 square. Is there anything having Q1 square here? Yes, this is Q1 square. So minus 0.1 Q1 square minus 0.1 Q1 square should give us minus 0.2 Q1 square. Okay. Then we have 410 Q2. Is there anything having Q2 only without any other? No. So write plus 410 Q2. Okay. So this is also gone. Let's say minus 0.05 Q2 square minus 0.2 Q2 square. This and this, we can easily subtract them. So that should give us what? Minus 0.25 Q2 square. Okay, so left with this. So we have minus 0.1 Q1 Q2. Okay, then minus 325. So this is the profit function. Okay, so after getting the profit function, we can now go ahead and find a profit maximizing level of output. To find a profit maximizing level of output, we take the partial derivative of profit with respect to Q1, equate it to 0, and also take the partial derivative of profit with respect to Q2 and equate it to 0, and then solve the two equations simultaneously. So let's find the partial derivative of profit with respect to Q1 first. So that will be equal to, we are differentiating with respect to Q1. Okay. Q1 has an exponent of 1 here. When it multiplies, it becomes 520. Subtract 1 from the exponent, you have 0. So Q1 exponent 0 is 1. And 1 times 520 remains 520. So it remains 520. Then we are differentiating with respect to Q1. Okay, so there's Q1 here. These two here as an exponent multiplied by negative 0.2, you get negative 0.4. Okay, Q1 exponent 2 minus 1. Okay, and 2 minus 1 is 1, so that's why we leave it as Q1. Okay, there is no Q1 here, so this is a constant, it's 0. There's no Q1 here also, so it will be 0. But there is Q1 here. You know, the Q1 here has an exponent of 1. When you multiply the whole thing by 1, subtract 1 from this exponent. So you have Q1 exponent 0. And Q1 exponent 0 gives you 1. So when you differentiate this with respect to Q1, it should give you minus 0.1 Q2. Because Q1 exponent 0 is 1. And when you differentiate this, it gives you 0. So partial profit, partial Q1 is 520 minus 0.4 Q1 minus 0.1 Q2. We set it equal to 0. So that is equation 1. Then let's also differentiate profit with respect to Q2. So differentiating profit with respect to Q2, there is no Q2 here, so it's 0. There is no Q2 here also, so it's 0. But there is Q2 here. So when you differentiate this with respect to Q2, you get 410. Okay. And then let's differentiate this also with respect to Q2. 2 times 0.25 will give you minus 0.5. Okay. And then we subtract 1 from the exponent. That becomes Q2 exponent 1, which is Q2. Okay. Then let's also differentiate this with respect to Q2. Q2 here has an exponent of 1. Multiply by the whole thing and subtract 1 from the exponent. So you have Q2 exponent 0 also. And Q2 exponent 0 will give you 1. 1 times Q1 times 0.1 or negative 0.1 should give you minus 0.1 Q1. Okay. We also set this equals 0 and that is equation 2. So now we have equation 1 and equation 2. Now we solve equation 1 and equation 2 simultaneously. Now it's either we use the substitution method or the elimination method. But I want to use the substitution method, okay. Now to use the substitution method, I've decided to make Q2 the subject from equation 1. So when I make Q2 the subject from equation 1, I'll get 5,200 minus 4Q1. Okay, Q2 will be equal to 5,200 minus 4Q1. When you bring this negative 0.1 Q2 here, and you divide through by 0.1, this is what you get. Okay, so when you get Q2 to be equal to 5,200 minus 4Q1, then we substitute this into equation 2. So let's do the substitution. So we have 410 minus 0.5 into bracket 5,200 minus 4Q1 minus 0.1 Q1 okay, equals 0. So let's simplify what we have in the bracket. So we have 410 minus 0.5 times 5,200 will give us, that should give us 2,600. Okay. And then negative 0.5 times negative 4Q1 should give us what? Positive 2Q1. Then minus 0.1 Q1 equals 0. Okay, now this one we can easily subtract. So 2Q1 minus 0.1 Q1 will give us what? That will give us 1.9 Q1 equals, now 410 minus 2,600. That will give us negative 2,190. Okay, negative. Then when we bring it to the side, it becomes positive. So positive 2,190. But we want to find Q1. So we divide both sides by the coefficient of Q1, which is 1.9. Okay. So this 1.9 cancels this 1.9. So we have Q1 to be equal to. So when you put 2190 divided by 1.9 on your calculator, it will give you 21900 over 910. Okay. And you can convert it to decimal. So in decimal, it will be 115 to 0.63. Okay. So Q1 is equal to 1152.63 in decimals. Okay. Now that we know Q1, we can easily get Q2. You know, when we made Q2 the subject here, it was 5,200 minus 4Q1. So let's recall Q2 and substitute the value of Q1 in it. So we have Q2 to be equal to 5,200 minus 4 multiplying what Q1. Now, I don't want to put the decimal Q1 in it. I want to put a fraction one. Because I think when I put a decimal, I won't get a proper approximation. Okay, so let me substitute the fraction one in it. Okay, so when you put this also on your calculator, in fraction, you get Q2 to be equal to 11200 divided by 910. That's in fraction. But in decimals, Q2 will be equal to 589.47. Okay, so Q1 is equal to 1152.63 and Q2 is 589.47 in decimals and in two decimal places. To confirm if profit is maximized, okay, second order partial derivative of profit with respect to Q1 times second order partial derivative of profit with respect to Q2 should be greater than cross order partial derivative of profit square. Okay, if you want to confirm if something is minimized, it should rather be less. Okay, but to confirm maximization, the product of these two should be greater than the cross order square. So what will be the second order partial of profit with respect to Q1? Now this is partial with respect to Q1. Second order means that you should differentiate this again with respect to Q1. And when you find the second order partial derivative of profit with respect to Q1 again from here, second order, that should give you negative 0.4. Okay, so you get negative 0.4. Then the second order partial derivative of profit with respect to Q2, which is this, let's differentiate with respect to Q2, to give us negative 0.5. And then what will be the cross order partial derivative? The cross order means that you should differentiate partial profit partial Q1 with respect to Q2. Or you can also differentiate partial profit partial Q2 with respect to Q1. Either of them will still give you the same answer. So when I differentiate this with respect to Q2, I'll get negative 0.1. So the cross order is negative 0.1. Now, when you multiply 0.4, negative 0.4 and negative 0.5, what do you get? You get positive 0.2. And negative 0.1 squared, which is a cross order, should give you positive 0.01. So you realize that 0.2, which is the product of the two second partials, is really greater than 0.01. So since it is greater, then it means that profit is actually maximized at those output levels. So we conclude that hence the profit maximizing level of Q1 and Q2 are 1152.63 and 589.47 respectively. Okay, so that's the final answer to question A. Let's go to question B. Question B says, we should find the profit maximizing prices. Now to find a profit maximizing prices. Now look at something. From here we have P1 as the subject and we also have P2 as the subject, isn't it? But since we know the profit maximizing levels of output, we can substitute them in these two equations so that we can get the profit maximizing prices as well. Okay, for question B, to find the profit maximizing prices, let's recall P1. P1 was equal to 520 minus 0.1 Q1. So then we substitute the profit maximizing level of Q1 in. So we have minus 0.1 into bracket 21900 divided by 19. That's the fraction 1. So P1 will be equal to, so when you put this on your calculator, 520 minus 0.1 multiplying this, you get 7690 divided by 19. Okay, you can convert it to decimals. In decimals, you get 404.74. Okay, so that's the answer to P1. Then to find P2 also, we recall what we got for P2. P2 was 410 minus 0.05 Q2. And then we substitute what we got for Q2 in. So P2 will be equal to 410 minus 0.05 multiplying 11200 divided by 19. So when you put this also on your calculator, you get P2 to be equal to 7230 divided by 19. Okay, which you can also convert to decimals. So in decimals, it will be equal to 380.53. Okay, so these are the profit maximizing prices. Okay, and C says we should find the maximum profit. To find maximum profit, okay, you recall the profit function. What was the profit function? This is the profit function, isn't it? Now, when we recall the profit function, then we substitute the profit maximizing outputs in it. Okay, that's Q1 and Q2. What we got for the two of them, we substitute in it. So when we substitute, we have maximum profit to be equal to 520 multiplying Q1. Our Q1 was what? 21900 divided by 19 minus 0.2 Q1 squared plus 410 Q2, which is 11200 divided by 19. Okay, minus 0.25 Q2 squared, then minus 0.1 Q1 multiplying Q2, then minus 325. The maximum profit will be equal to, when you put all this on your calculator and you solve it properly, you should get 420,201.32. So the maximum profit is 420,201.32. Okay, so you add a currency to it. See this. If you are dealing with dollars, you write dollars. Okay. Then let's look at question D. Question D says we should find the marginal cost of commodities 1 and 2. So to find the marginal cost of commodities 1 and 2, first we recall the total cost function. Okay. This is the total cost function here. So when we recall the total cost function, we differentiate the total cost function with respect to Q1 to get the marginal cost of commodity 1, and also differentiate the total cost with respect to Q2 to get the marginal cost of commodity 2. So let's do that. So marginal cost of commodity 1 should be equal to partial TC partial Q1. Okay, and that will give us, we are differentiating total cost with respect to Q1. These two will multiply 0.1, it will give you 0.2. So let's write the 0.2. Then subtract 1 from the exponent, you have 1. So Q1 exponent 1 remains Q1. Plus, we have Q1 and Q2 here, so we can differentiate. We are differentiating with respect to Q1. So you have Q1 as an exponent of 1, multiplied by 0.1, it remains 0.1. Now, Q1, when you subtract 1 from its exponent, it becomes 0. Q1 exponent 0 is 1, and 1 times Q2 will give you what? Q2. There is no Q1 here, so this place will become 0. No Q1 here is 0. So marginal cost of commodity 1 is 0.2 Q1 plus 0.1 Q2. To find marginal cost of commodity 2, which is MCQ2, equal to partial TC over partial Q2. Okay, so it means we should differentiate TC with respect to Q2. So marginal cost of commodity 2 will be equal to, now to differentiate TC with respect to Q2, for the first term, there's no Q2 there, so it becomes 0, so we won't write. But in the second term, there is a Q2, and it has an exponent of 1. Okay, so when you multiply the whole, or let's say you multiply 0.1 by 1, you get the 0.1, and then subtract 1 from the exponent of 1, it gives you 0. So Q2 exponent 0 is 1, and 1 times Q1 remains Q1, plus we are differentiating with respect to Q2, and Q2 has an exponent of 2 here. So 2 times 0.2 should give you 0.4. Okay, Q2 exponent 2 minus 1, and 2 minus 1 is 1. Q2 exponent 1 remains Q2. So marginal cost of commodity 2 is 0.1 Q1 plus 0.4 Q2. So that's the final answer to this also. So in the next video, we take another application question and see how to solve. Thank you.